open source tools. And you're going to hear about the good, the bad, and the ugly with it. So without further ado, I'd like to introduce Giorgio.
Thank you, Anne. It's a great pleasure to be here today. So my name is Giorgio Sardo. I work in Wrapup. I work in the Windows Evangelist team. And there are a lot of reasons why I love my job. But I think number one, I get the opportunity to work with very smart people. Either in the product teams like Windows, Internet Explorer, JavaScript, Visual Studio, but also with developers and communities, partners, design agencies around the world. I travel a lot and I try to meet as many developers as possible. And one of the developers we've been working with for this game in particular is Pixel Lab. It's a small shop based in Seattle, and they've been working with us producing this beautiful application. And so today I want to share with you some of these experiences. We will talk about games, and I want to share with you the experience of building this game. But before we get to cut the rope, just let me spend 1 or 2 minutes looking at how we got here in the last year or so. And so about 1.5 years ago, I remember, for the launch of IE9, we've been working on this site. And we were trying to demonstrate what you can do with HTML5. And so this is a game that you probably know, right? Have you seen this before? Yes? So you know that if I go down, whoops, and if I go left, okay, somebody need to send an email to my manager asking I need to play more. But you get the idea that I can keep going and going and going. And if I go home here, actually, it's not just 1 or 2 mazes, but we're talking about 80,000 mazes generated by users like you. So you can just go there and create your own one. And this is all HTML5, so HTML5 plus the cloud. And this was 1 year ago. And obviously, Pac-Man is a simple game. So what have we seen since then? Well, Google has been working on a funny new game. It's called, maybe you know it, Angry Birds. And they have this game working on the browser. It's all HTML5, almost all HTML5, and it's great, right? Lot of levels, lot of things. You already know Angry Birds, so I'm not going to show this today. And then Mozilla, more recently, came up with another great experience. It's called Browser Quest. And the thing I love about this game is that actually it's not just you against the computer, but it's you against other users. And so you connect to the web, and now you're using WebSockets to communicate and to play in real time with other users. This is kind of awesome, isn't it? I mean, technology is not just there to enable your little scenario, it's there to connect people eventually. And then more recently, this is more for fun actually, we came up with another small experiment, and it all started from a YouTube video, and it's all about marshmallows. So we call it Bored to Death. So you can play this where you really don't know what to do. So I start the level. And this is the game. And you might think, oh, this must be a very complex game. No, actually, all you have to do is punch people. And if you're bored of punching them, you can also put them on fire. Look at this. And I hit the cake.
I feel nothing.
And you can keep going and going. The goal here is to keep punching. Like as long as you stop punching, your boredom score goes up and you lose. All right. And so, what do all of these games have in common? It's a question. Try to answer. They are HTML5, and you're killing some people, but also they are HTML5. So we didn't use plugins, and so that actually is in line with our expectation, right? If you hear Microsoft in the last, let's say, 2-3 years, we'll be telling, oh, Microsoft is all in into HTML5, blah, 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 Internet Explorer is fast, blah, 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 hardware acceleration, blah, blah, blah. But actually, it makes sense. Look at the progress. This was like what we implemented of the HTML5 specification about 2 or 3 years ago. This is what we have today. And this is coming from the work with W3C, with our browser vendors, with other browser user agents, and with a lot of people in the communities. And this spectrum of HTML5 spec is getting bigger and larger and better, right? Like there are maybe 100 specs on this page that we already support and actually already supporting in all browsers. And you can do pretty amazing things with them. And the best thing about what we do in Microsoft, that in addition to be standard compliant, we also work on performance. Now, let's forget about Microsoft. This is not a Microsoft talk. But the interesting part, the part here is, my team works on demonstrating, like on the bleeding edge of technology, and we try to see where is the HTML5, where is the technology going after later. And we try to demonstrate it with real application. And so we thought, can we take all of this marketing message that the IT team is creating and validate it, right? Is it true or is it just marketing stuff? And so we thought, let's create a challenge. Let's take a native application, a native game running on iPhone and iPad, and let's turn it into HTML5. And this is what we did with Wrapup. So now I'm going to share with you some of the code, some of the learning, and some of the process we went through to take a native application on iOS into an HTML5 application running in any browser. So it's not IE, right? Running in any HTML5 powered browser. Do you know Wrapup, or do I need to do a demo? Do you know Wrapup? Have you seen the website of Wrapup before? Okay, most of you did. Excellent. So let's start with the basic. Let's start with some code. Wrapup is written in, obviously in Objective-C, about 40,000 lines of code. One of the first principles that we set when we started working on this project is that we didn't want to lose fidelity. We wanted to have exactly the same experience on JavaScript as it was on Objective-C. So there are 40,000 lines of code in Objective-C, and we did the porting of the lines of code one by one into JavaScript. And that was not too difficult, but there is definitely some learning there. And on the graphics side, we started from OpenGL, and we turned it into mainly a canvas game. And so let me show you the game after probably a few hours we were working on it. So you recognize this, right? How does this work? How are we doing this animation? Here's the trick. Let me show you what we call sprite. This is an image with a lot of different frames. And so in the canvas, then we animate very quickly over this window, and we create the effect of having an animation. So if I show you the code behind, actually let's go to script, it's all here. So this is all it takes to create this animation. Let me zoom in for you. We have a canvas. We set up the canvas and we add it dynamically to the page. And then we have a drawing loop. Just a basic, we're not doing any optimization yet. Just a basic loop. Every 60 milliseconds we loop into this drawing loop. We clear everything that's on the canvas and we draw an image. And that image is coming from, moving very quickly over that large sprite that you saw before. And this gives you a nice animation. This was easy. Now let's get to the complex part. What we learned building this application is that the ropes were actually the biggest trouble for this app in terms of performance. And let me spend a couple of words on this. What you see as a rope there is actually not a line, it's not a bezier. It's made of 20,000 triangles. Little triangles next to each other, and then they give you the idea of being a rope. Why? Because in OpenGL you don't have anti-aliasing, and so the way the iPad developers worked it around was creating all of these triangles. And by the way, on top of those 20,000 triangles, you have other 10,000 triangles to create the shadow on the edge. And so we basically end up having an algorithm in JavaScript that was animating 30,000 triangles at every drawing loop. That's quite a lot, right? Turns out in HTML5 this is easier because the canvas spec implements natively the Bezier line. But still, we had to do some work to optimize the code. And so let me show you the application running before. So this is what the code was looking before. And on the right, you see the code optimized later. And then I'm going to show you the code. You see the difference? You see it? Yes? No? It's kind of obvious here. Now let me show you the code instead. So this is just a line. What do you think? Is this slow or is this fast? Fast? Actually, no, this is slow. I didn't know. Actually, at this point, Zeptolab is the company that owns this game. We sent this page to Zeptolab back in Russia, and they come back with an email saying, "Hey, Giorgio, this is embarrassingly slow." And I was looking, oh, what are they talking about? We should stop the project here. I was like, what? But then, I realized that if you use like a JavaScript profiler, and most browsers have a JavaScript profiler now. Actually, sorry, this one. And we provide this JavaScript. I'll show you what's going on behind the scene. Right? So we're just capturing, I'm using the F12 now to capture like a profile session of the JavaScript. And you will see that a lot of time is spent on vector and also on calc 2-point Bezier. Those are, this is where the JavaScript is spending most of its time. And we're talking about 2 seconds just allocating vectors. And so let's try to understand why it's spending so much time. And if we go inside vector, we will see, well, it's just a vector function. What's wrong about this? If we go inside this is what's wrong. New vector. And so think about this calc point Bezier is basically the function that calculates the position of all of those little triangles. If we call that 30,000 times, and each time we create a new vector to return a result, and then we dispose it immediately after to send it to the garbage collector, you're paying a big cost, right? And there are ways to optimize this code. And so in the next session at 5, I will actually go even deeper into this, and I will show you how we optimize this code. And so at this point, we were almost about to close the project and to go home and to lose my job. And I was crying. But then we kept, the day after we realized that it was possible to optimize the JavaScript code. And so the learning was, if your JavaScript code is low, maybe you didn't write it right. You didn't write it in the right way. Try to look again into it. And use JavaScript profiler to fix it. And after 4-6 weeks, we got to this, which was amazing, right? We have the basic element, and then it's kind of buggy yet. We didn't complete all of the code, but it was mostly working. And this was already awesome. Like I was already dancing in my office. Yes, I'm gonna keep my job. This is gonna work. And this was easy, right? And then from this point on, the next step was just to keep building the game. And so let's have a look to the code behind that page. The body is only a canvas, right? We're using only a canvas element to draw all of the game. Then we call obviously all of the code to start up the game experience. And then I also wanted to note here that we're using jQuery. There are things in the application that are not canvas only. And we wanted to use a framework because it was silly to rewrite some of the code, and we decided to go for jQuery. And lastly, we also created, with the help of Pixel Labs, a preloader to load all of the images and sounds, and this is available. So this is made open source, and you can use it if you're doing a game. Other interesting tidbits here. If I go inside maps, you will see that actually each map is defined by an XML file, which means that we created the engine, but once we have the engine, you can go and build as many levels of the game as you want. So this was all a fun project to work on. We will look later in the next session a bit closer to the performance, and I will share more of the details, but I wanted to give you a very, 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 very high view of other tools and other possibility to go into the browser, no matter what browser you are, but into the browser, and look actually at how the CPU is spending cycles on each of, for example, on different sub-engines. And so, for example, we can see here This is called Xperf. It's a free tool that comes with the Windows SDK. It actually tells you how much milliseconds are spent by JavaScript, by the layout, by display, etc., etc. So this is another interesting tool to help you optimize the code at a very low level. And we will get into the details later. And then, about 8 weeks, 12 weeks into the project, we finally got to this point. So this was the full game running as HTML5 experience. Click, click, and then you can just play. Champion. Champion of the world. Now, this was a fun project to work on, but here's the best line about this, the best thing about this. When we got here, then we sent back the website to the Zeptolab company in Russia. And we were like, what do you think? Do you like it? Is it good? Is it not? And the next day, I get this email saying, I'm quoting, this is too fast. Can you please slow it down? And I was like, yes! And so we did a bit of negotiation there. But eventually, we end up just slowing it down. So, if you actually look at the code of this game, we had to add other JavaScript to slow down the game. Yes?
So, why did you want to game it slower? And so is this could be run on the mobile as well, or is only for desktop?
So the question is, why did they ask to make it slower, right? Does it run only on the desktop or run on the iPad? Or other devices in general. So on the why they ask for this slower is because you know your game better than anybody else. You have your own requirements, and you know what the user expects from you. And also they were used to a different performance on other devices, and they didn't. I think as an end user, you would be surprised to see that you get a different playability, different gaming experience on different devices. And then obviously I will need to defer to them to give you all of the reasons. In terms of which platform we targeted this, we used IE to develop it, but we tested on all browsers. And we made sure actually we had a QA process to work on Chrome, on Firefox, Safari, Opera, iPad, Android, Windows Phone. So we actually tested on all browsers. It wasn't our goal to make it work only, to lock it to one specific browser. And in terms of performance there, one of the decisions we made up front in the process was to say we expect the browser to be at least able to play at 30 frames per second. And so you will see that if you start playing the game on a mobile device that is slow, maybe starts with the A, you will play the first game and it works so-so. And then we will prompt a message saying, hey, maybe you're not playing at the best experience. Try to either move to a faster browser or play at your own risk. And so I will do a QA about this game, and I will answer any question that you might have in my next session. We have like half an hour only for QA about this game because I know that you have a lot of questions. But I want to show you something else here, very quickly. And so at this point we were almost 2 weeks away from releasing Windows 8. And I work in Windows. And part of the things we did in Windows 8 was reimagining the platform to allow you to reuse your HTML5, your skills, to create applications and to sell these applications in the store. And so I thought actually at that point, what does it take to take what we did for the web and let's see if it works as an application for Windows. And so that's what I did that day. I went, and I'm going to do just a step-by-step. I just opened up Visual Studio, is our tool environment. I created a new project for a Metro application in HTML and JavaScript. So this is the new Windows 8 Metro app. Okay, I'm just choosing a default template. I'm not doing anything here. And Visual Studio will create the template for me. Okay. So far it's just an empty project. And so on the right, I have my application, and on the left, I have the website. So I take the website and go to the file system, and I select all of the files, and I just copy them. Copy. We don't need this anymore. And then I go to my Metro application, and I say, paste. and then I just overwrite everything. Okay? And then the other thing I need to do in the manifest, which is just an XML file that defines some of the property of this application, like ties and orientation, etc. I just switch the default start page to be index. Right? Ready? Now I compile this application and I run it as a local application on my machine. So Visual Studio is packaging this code. Boom. What do you think? And by the way, this is also touch friendly, right? So this is a touch screen. I'm using a laptop with a touch screen, and so I can just play with my finger. You will see my pointer here. So that was what it took us to go from web to Metro. Now, what I just showed you is horrible. Horrible. Don't do it at home, right? Like, we're not asking you to copy and paste websites into application. No, don't do it ever, please don't. I just wanted to prove the fact that you can take your code, your skills, and just reuse them super easily to build an application that goes through the Windows 8 store. So that was it. And also, actually, if you look at this application and the application that we end up publishing to the store, they're quite different. Right, this one, for example, is full screen, allow you to share with your friends the context of the game. If I click options, is integrating into the operating system. Allow me, for example, to play side by side. So if my manager is around, no manager, I'm writing code. Seriously, I'm writing code. You know, and then, no, actually, I'm playing. And a number of other things. So we did extend that further to be an application. And in the next session, I will talk through also a bit of the tricks to get there very quickly. And the other thing I wanted to show you is another tool that you might actually like, I think. So I'm opening now the full project. So this is the final HTML Metro application. And I'm going to open it with a different tool called Expression Blend. And by the way, all of these tools are free, so they work on Windows, obviously, but they're free. And this is called Expression Blend. And what we tried to do with Expression Blend was to create a tool to really build complex applications. And one of the challenges that you have today, when you develop a website or when you build an application, is that you don't see it until the time where you actually open it in the browser. So do you notice anything about this tool? It's slow. Okay, what else? Look closely. You see the background? It's moving. You see that shadow? It's rotating. So we are actually editing a page built by JavaScript. You're not editing, like if you open this in any other web editor today, you will get static HTML with no preview. Now we're editing a page that is running. It's a live page. And it's running, you remember I told you it's all built by Canvas, right? I can even go into the game and start playing the game and go to the video and then select, for example, one level. Now I'm in the game, I freeze it and I say, hey, I want to keep building this page from here. And so the tool is running JavaScript to animate and to create all of this UI. This is all built in real time with JavaScript. But still, you can edit it, and you can move the CSS, and you can see things as they will look like. And so if you build like JavaScript applications, and you know like the pain of not being able to see what you're building dynamically, this is our approach to fix that problem. And obviously, as you can see, it's quite complex. So there are many other things involving this tool, from CSS, styling, to, for example, being able to preview on different resolutions, on snap view, etc., etc. What do you think? Is this useful? I have to say, like, this is one of the things I'm most excited about. Like, it took us a lot of years to get here. But now that I think about it, it's kind of obvious, right? Like, we're asking you to build complex HTML applications and JavaScript applications, and without this, it's difficult. It's very difficult. And so, in this session, I just show you a quick overview of our experience building the game. In the next session, I think it's at 5 p.m. This afternoon, we will get into the specific code, and I will show you some of the code behind, and I will talk about performance tricks that we use to optimize loops algorithm. I will talk about sounds. I will talk about compatibility and things we have to do across browsers. I'll talk about touch, but most of all, I will answer any question that you might have. In the meantime, we are hiring a Windows 8 evangelist to work on HTML5 apps, and so to build other cool stuff like this. So if you're interested, just ping me. I want to thank you for your time, and I'll see you later. Thank you.